26. The following pairs of equations show how the x and y coordinates of a particle vary with time t. In the equations, a, b, and omega are non-zero constants. Which pair of equations can describe the path of a particle that moves with a constant speed and with a non-zero acceleration that is constant in magnitude? In the first place, we have to consider that from a calculus point of view, the components of your velocity are going to be the derivatives of position. Vx is equal to dx dt, Vy is equal to dy dt, and we will have a constant speed if those components result in a constant value according to the Pythagorean theorem. Now, in the case of option B, what we have is Vx is minus a omega sine of omega t, Vy is minus 2a omega sine of omega t. Clearly, the Pythagorean theorem with these values will not yield a constant. In the case of option C, Vx is A and Vy is B. Therefore, the square root of A squared plus B squared is constant. However, the acceleration ax is 0, ay is also 0. This requires a non-zero acceleration, so that doesn't work. On the other hand, option D, the velocity in x is 2at, the velocity in y is 2bt, and our problem here is that the square root of 4a squared t squared plus 4b squared t squared is not a constant value since it depends on the time, so the speed is not constant. The same thing happens for option E. In that case, Vx is A, Vy is 2bt, and the speed a squared plus 4b squared t squared is not independent of time, so it is not a constant speed. Option A, however, has an x velocity equals to minus a omega sine of omega t, and a Vy equals to a omega cosine of omega t. And if you do the speed by taking Vx squared plus Vy squared, then you're going to end up with square root of a squared omega squared times sine squared of omega t plus cosine squared of omega t, and according to trigonometry, that parenthesis is actually equal to 1. So what we have here is the constant a omega. On the other hand, the acceleration ax is equal to minus a omega squared cosine of omega t, ay is equal to minus a omega squared sine of omega t, and a simple calculation shows that the acceleration in magnitude also includes sine squared plus cosine squared, and so the final answer is a omega squared, which is also constant. Therefore, the only choice that allows for constant velocity and constant acceleration is option A.